Well, of course, you knew we were going to have to do some calculations, right? We can relate the amount of heat needed to warm something up with the temperature. And here's the basic equation. The heat is equal to the mass of the substance times the specific heat capacity times the temperature change. Or in a more abbreviated form, Q equals mc delta T. So that's an equation that you should memorize. Q equals mc delta T. The delta kind of looks like an A, and so sometimes we say Q equals MCAT. I don't know. If that works for you, great. Delta means change in. So here we have our legend of what these things are. Q is the amount of heat in joules. M is the mass of the substance in grams. C is the specific heat capacity in joules per gram degree Celsius. Delta T is the temperature change in Celsius. That delta symbol stands for change in, and it's always the final minus the initial. And here the sign is important. So it's the delta T equals the final temperature minus the initial temperature. So if we have, say, a mass of 100 grams of something and we're warming it up, that's going to take less energy to heat than 1,000 grams, right? You kind of know that from everyday life. If you're trying to make spaghetti on the stove, right, you're trying to heat up a pot of water to boiling. Well, I've had to feed the football team. We have to put on these team dinners. And so, we need to cook spaghetti for 50 hungry boys, right? So then you get out the giant stock pots of water. Regular pot to make a spaghetti for 1 or 2 people might take 10 minutes to boil the water, 15 maybe. Those big pots, even on a really big commercial stove, 45 minutes to boil water. Why? There's more water. If you have more stuff to heat up, it's going to take more energy. The stove can only put out energy so fast, right? The other thing is the change in temperature, which is going to boil faster. Let's say we kept the amount of water constant. We had one pan with cold water from the fridge and another with hot water from the tap. Not boiling, but hot water. Which one's going to boil first? The hot water, right? Because the change in temperature is less. The stove is putting out heat at the same rate, but when you have a smaller temperature change, it doesn't require as much energy. Okay, so let's do this problem. This one has a lot of words in it, doesn't it? We got to read all the words first. You find a copper penny in the snow and pick it up. How much heat is absorbed by the penny as it warms from the temperature of the snow, minus 5 degrees Celsius, to the temperature of your body, 37 degrees Celsius? Assume the penny is pure copper and has a mass of 3.10 grams. You can find the heat capacity of copper in table 3.4, which is on page 71. Or we can just go back here. We need the heat capacity of copper. 0.385 joules per gram degree Celsius. Okay, so 0.385 joules per gram degree Celsius. And then I'm just going to identify what these numbers are. I have minus 5 degrees Celsius, and I have 37, that's not a 3. 37 degrees Celsius, and I have 3.10 grams. Pre-1982, as they've started making pennies differently after that. So those are the numbers from the problem. I know a lot of you have a hard time converting sentences like this into math equations. Read through the whole thing, pull the numbers out and write those down with their units. Now let's look at these things and say, well, what are these? Well, this actually says mass of, right? So that's probably the mass. The mass equals this. And then we've got two temperatures, right? Here's a temperature, and here's a temperature. And this, we looked up, that's the specific heat. The specific heat is abbreviated by a capital C. This is not a problem that we're going to do using dimensional analysis. We're going to use an equation for this one. The equation we just talked about. Q equals mc delta T. So we've found the equation. And now we need to make sure that we've got the right things to plug into this. What are we trying to find? What's the question part? How much heat? So we're looking for how much heat. In this equation, which letter stands for heat? It's the Q. So this equation is already arranged for us. We need to find out what M, C, and delta T are and stick them in there. Well, here's our M. That was handed to us. Here's our C. We looked it up. We need delta T, the change in temperature. It's the final minus the initial. Delta T equals T final minus T initial. Well, we've got two temperatures here. Which one is the initial temperature? The -5. So we're looking at this, and it's like as it warms from the temperature of the snow, from this to that. So 37 is the final, and -5 is the initial. So delta T then is -5 minus 37. No, I did that wrong. It's 37 minus -5. Your calculator can handle that. I know the double negative is confusing. 37 minus, and then I'm going to do that change sign thing, -5 equals 42. So the change in temperature was 42. Because it was below 0, it had to come up to 0, and then it went 37 above that. We've identified all of our quantities here. We're going to plug them in. The mass was 3.10 grams. Always write your units in here. This is 0.385 joules per gram degrees Celsius. Write that as a vertical fraction. And then our change in temperature was 42. I was sloppy down there. Let me fix that. Oops. My calculator said 42. But both of these had one decimal place. This is really 42.0. Okay, so now I just do this multiplication. 3.1 times 0.385 times 42 equals. I'm going to write down what my calculator says. 127. Now let's look at those units and see what happens. Well, here I have a gram that's in the numerator and a gram that's in the denominator. When you write this as a vertical fraction, it's easier to see what's on top and what's on bottom. This gram cancels with that gram. And here I have degrees Celsius in the denominator and degrees Celsius in the numerator, and those cancel out. And the unit that's left is joules, a unit of energy. How many significant figures should our answer have? 3. This is 3 sig figs, this is 3 sig figs, and that's 3 sig figs. So we should call this 50.1 joules. Any questions? Here's another one. The temperature of a lead fishing weight rises from 26 degrees Celsius to 38 degrees Celsius as it absorbs 11.3 joules of heat. What is the mass of the fishing weight in grams? Well, let's pull the numbers out and write them down. We've got 26 degrees Celsius, and we've got 38 degrees Celsius, and we've got 11.3 joules. The unit here tells us those are temperatures. The word tells us too, but temperature. We identify the initial temperature and the final temperature from the description that's given, right? The temperature rises from 26 to 38. So 26 is the initial temperature, and 38 is the final temperature. It absorbs 11.3 joules of heat. What's the letter abbreviation for heat? Q. And don't ask me why, because I have no idea why Q is energy, but it is. And what do we want to find? Mass. Mass equals question mark. Well, we've got temperature and we've got energy. We probably need that MC delta T equation. So let's write that down. Q equals MC delta T. This time we're trying to find the M. We're going to have to rearrange this, aren't we? I want M by itself on one side of the equal sign. I need to make C and delta T go away, essentially moving them to the other side. Yeah, so I'm going to divide. If I divide this side by C, C over C cancels out. But in order to keep it an equality, I need to divide the other side by C as well. To make the delta T go away, I divide by delta T. Delta T over delta T is 1. But I have to divide by delta T on the other side also. And that's all kind of messy, so I'm just going to copy it down. M equals Q over C delta T. So I need Q, I need C, I need delta T. Well, I've got Q. I've got two temperatures, so I can find out what delta T is. Delta T is T final minus T initial. So that's the final 38 minus the initial 26. So that should be 12, right? I have Q, I have delta T, I don't have C. What am I going to do? Look it up. They told me this was a lead fishing weight. Lead is an element. If we go back to this table, and we've got lead, its specific heat is 0.128 joules per gram degrees Celsius. C equals 0.128 joules per gram degrees Celsius. Now I have all three of those numbers. So I'm going to put them into this equation. So Q is 11.3 joules. And then down here I've got C, 0.128 joules per gram degrees Celsius. And delta T is 12 degrees Celsius. If you rearranged your equation correctly, the units are going to work out nicely. Here I've got degrees Celsius divided by degrees Celsius. Those cancel out. I have joules divided by joules. Those cancel out. The unit I'm left with here then is 1 over G, which does equal grams. And If you don't want to think about that, that's fine. Now I need to do this on my calculator, and you need to be careful. What a lot of students want to do is they want to take this number, divide by that, multiplied by this. Your calculator doesn't understand that you're trying to do 11.3 over the quantity 0.128 times 12. So I'll tell you what I do. The other way you can do it is you can put parentheses around those two numbers in the bottom if you just really feel like you have to multiply. But get your calculator out if you haven't gotten it out yet, and make sure that we can all come up with the same answer. So what I'm doing is I'm doing 11.3 divided by 0.128, and it's also divided by 12. My calculator gives me 7.35677 and some other things, grams. If you come up with 1059, you have a communication error with your calculator. So you can do 11.3 divided by, open parentheses, 0.128 times 12, close parentheses equals, or you can just divide by both of the numbers in the denominator. Anybody have any questions? Yes. Sig figs. Yes. How many should it have? 2. These are the numbers. We've got 3 sig figs here, we've got 3 here, and this temperature is only 2 sig figs. So we'll round this to 7.4 grams. Any other questions? Oh, this is a fun one. I understand that's a relative term. A 328-gram sample of water absorbs 5.78 times 10 to the third joules of heat. Find the change in temperature for the water. If the water is initially at 25 degrees Celsius, what is its final temperature? Read all the words, pull out the numbers. So 328 grams, and I've got 5.78 times 10 to the third joules, and I have 25.0 degrees Celsius. Well, 328 grams. Gram is a unit of what? Of mass. So that must be the mass. And it says it absorbs this much heat. The symbol for heat in these equations is Q. And then 25 degrees Celsius is a temperature. Is that the initial or final? That's the initial temperature. There's 2 questions here. What's the first one? The second one is, what's the final temperature? The first one is, it's actually not a question, find the change in temperature. So the first thing they're asking me to do is find delta T. Delta T equals what? Well, we're going to pull out our little equation. Q equals MC delta T. This time, though, I'm looking for delta T. So I'm going to rearrange this so that delta T is all by itself. So I'm going to divide by the other things. I'm going to divide by M and by C. M over M cancels out, C over C cancels out. I have to do the same thing on the other side of the equal sign. The change in temperature equals Q divided by mass and specific heat capacity. What am I missing? I don't have the specific heat capacity. You have to go look that up in the table. I happen to remember that one, 4.184 joules per gram degrees Celsius. So now we can plug these numbers in. We've got 5.78 times 10 to the third joules divided by 328 grams and 4.184 joules per gram degree Celsius. The joules cancel, the grams cancel. I've got 1 over Celsius, which is just Celsius. Again, be careful. We're dividing by two numbers. 5.78 EE3 divided by 328 divided by 4.184. So delta T equals 4.2117, bunch of other digits, degrees Celsius. If you got 73, you've got a calculator communication issue, okay? And the easiest way for me to help you with that is in person, one-on-one. So how many sig figs would that answer have? Bless you. 3, right? Because we've got 3 and 3 and 3. So the change in temperature is 4.21 degrees Celsius. That's the first thing we're asked for. Then they ask, what is the final temperature? Well, we're going to use our delta T equation. Delta T equals T final minus T initial. We want to know what the final temperature is. We want to keep this guy. So we're going to rearrange this by adding initial on each side. And we end up with the final temperature being equal to the initial temperature plus the change. So the final temperature equals the initial temperature, which was 25, plus the change, which is 4.21. And so the calculator gives us 29.21. And how do we round that? Those pesky sig figs.
It's addition, so it would be number of decimal places.
Correct. It's addition, so we look at number of decimal places. This has 1 decimal place, this has 2. So we're going to round our answer to only 1 decimal place, and we're going to say that it's 29.2 degrees Celsius. That's our final temperature. That's the other thing that the question asked us to find. Any questions?